Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. And here you can find information about online seminars that I teach for exams P, FM, IFM, and LTAM, and the study manuals for the same exams that I authored. All of them are under the brand name BTDT, which stands for Been There, Done That. That's the feeling you need to have every time you look at a problem on the test. You're not going to invent anything new on the test. You have to be so prepared that you know immediately what to do when you look at every problem on an actuarial exam. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. Our program is a Society of Actuaries Center of Actuarial Excellence, and we won a Casualty Actuarial Society University Award. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for today for exam LTAM. It's problem number 10 from exam LTAM offered the first time ever in October 2018, just about a little bit less than a month ago. Not from this date listed here. I'm recording this earlier, but it's about a month ago. For a special, and this is where I'm going to put the video, for a special 10-year deferred whole life annuity due on 50 and 60-year-olds, two people, you are given, so it's 10-year deferred. At the end of the deferral period, if both lives are alive, the annuity contract terminates with no payment. Ouch. If exactly one is alive, a benefit of $9,000 per year is paid until the second death. The future lifetimes of 50 and 60 are independent. Mortality follows the standard ultimate life table. Interest rate is 5%, which is the rate in the standard ultimate life table. Always check that. Calculate the expected present value of this special annuity. Since the future lifetimes are independent, probabilities of payments being made, 50 lives 10 years but 60 dies, or 60 lives 10 years but 50 dies, that's when the payments happen, can be calculated as products, and because the probability of those events, what happens to 50-year-old and what happens to 60-year-old, the probability of those two happening at the same time is the product of probabilities because the lives are independent. So the expected present value of this special annuity is, well, the payment of $9,000 starting 10 years from now, when, if 50 survives 10 years and 60 does not, and the probability of that is 10p50 times 10q60 times, what's the present value of a life annuity paid to that 50-year-old who survives 10 years and becomes 60-year-old then. It's A$60 for a unit payment, and it's an annuity due. And also, the payment is made if if 60 survives 10 years and 50 does not. Okay, I'm sorry, I was confused because I was looking for the first 60-year-old survival in the first expression, but it's I explained it first, but it's second in the product. So 10q50 means that 50 does not survive in 10 years, 50-year-old, and 10p60 is the probability that 60-year-old survives. And that 60-year-old, when 10 years pass, when the 60-year-old still survives, is now a 70-year-old, and the present value of a unit annuity due paid to that person for life is A$70. Okay, so that all is 9,000 times, if you multiply 1.05 to the negative 10th times 10p50, that's 10e50. So 10E50 multiplied by 10Q60, which is 1 minus 10P60, times A double dot 60, then times 1 minus 10P50, which is the same as 10Q50, times, well, 1.05 to the negative 10th times 10P60 is 10E60, times A double dot 70. Why am I doing this weird thing with 10E50 and 10E60? Oh, because those two are given in the SULT table. Now, we will also try to do the same trick with 10P60 and 10P50 that we have there. If we multiply them by 1.05 to the negative 10, what we get is 10E60, but we don't have 1.05 to the negative 10 there. So we're going to invent it and put it together with 10P60 to make it into 10E60, but because we multiplied by 1.05 to the negative 10, we now have to multiply the resulting expression by 1.05 to the 10th to keep the value the same. And we do the same with 10P50. Okay, and now every single thing that you see in that expression can be looked up in the table or just written out as a number. So this becomes 9,000 times 0.60182, that's 10E50 from the table, times 1 minus 0.57864, that's 10E60 from the table, times 1.05 to the 10th, times 14.9041, that's A double dot 60 from the table, from SULT. And then plus 9,000 again. Well, what I did is just split the expression into 9,000 times the first one, plus 9,000 times the second one, not because that makes things simpler, but otherwise I could not fit this whole thing in one line, and that would be too big, so I needed to split it, so that's why. So this becomes 9,000 times 1 minus 0.60182 times 1.05 to the 10th, times 0.57864 times 12.0083. That's A double dot 70 from the table. And we calculate it, and it comes out as 5,870.122.541. The dot there needs to be corrected. So my apologies, I had a decimal point twice in the final answer, but now I corrected it, and what we get is approximately 5,870.122.541 as a result of the whole calculation that I indicated now in this big displayed formula. And that is answer E. Please remember, this is copyrighted material. The problem itself belongs to a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.